Hello all, welcome to Docker Basics to Brilliance course. My name is Kastro Kiran. In the last video, we have understood a concept that is related to containerization. I hope you now understood the concept of containerization and how containers has got evaluated over a period of time from physical servers to the containers. In this video, we are going to talk about a couple of important things that are related to the Docker concept. So firstly, we are going to talk about a brief introduction towards the Docker, and then we'll be understanding the architecture of the Docker, and we'll also be seeing what are the different components that are involved in the Docker architecture. Along with that, we'll be finally seeing the Docker workflow components. So these are the four things that we are going to discuss in this particular video. Now let us understand what is a Docker. Docker is basically a containerization platform that provides the ability to package and run an application in a loosely isolated environment, which is known as a container. Now, in order to create a container, we are going to use a concept called Docker, or we are going to use a tool called Docker. So in a nutshell, Docker is a containerization platform that is going to provide the ability in order to package the code and run an application in a loosely isolated environment, which is known as a container. This Docker is going to help us in order to deploy the application and to develop the application in an efficient way. So by using Docker, we can make the application development process and application deployment process in an effective and an efficient way. Docker is basically a platform as a service type model. By using Docker platform, we can create the services that are required in order to deploy the application in the form of containers. So that's basically about the Docker. Now let us deep dive into the concept of Docker here. So Docker is basically an open source and freely available software. And because of this advantage only, many of us are using Docker in the real-time scenarios. It's a free and open source software. And it is basically a platform independent service. So what does it mean by platform independent service? Docker can run on the EC2 servers. Docker can run on the servers that are created on Microsoft Azure Cloud. Docker can also run on the servers which are created by using GCP Cloud. That's basically a platform independent service. So it doesn't matter which cloud you are using, Docker has its ability to adapt to the environment that you are going to create. That's why we are going to call Docker as a platform independent service. And by using Docker, what actually we can do is we are going to create the containers. So we know that Docker is a containerization platform. So by using Docker, we are going to create the containers. But apart from creating the containers, Docker is also helpful in order to create an application, run an application, and deploy the application on top of containers. So this is also one more advantageous factor with respect to the Docker concept. And here, by using containers, what actually we can do is containers are something which will use the host resources like the CPU, RAM, operating system, and other types of hardware resources. Suppose, let's say you have installed the Docker on the Linux operating system. Then Linux operating system will become our host resource. That's called as host resources. Host resources is something in whichever operating system you are going to install the Docker, that particular operating system will become the host resource for the Docker. So that's about the Docker concept. Now let us understand what are the advantages of working with Docker. The first advantage of working with Docker is the portability and consistency. Now, what does it mean by portability and consistency? As we were discussing earlier, Docker is something that is platform independent. So it can run on any platform that is available in the market. So an application can be packaged in a Docker image, and this Docker image we can run on any system, but provided the Docker has to get installed. Once the Docker is installed on any type of operating system, such as Windows operating system, Linux operating system, Mac OS, Ubuntu, it can be anything. So Docker is actually a platform independent service and it can run on any kind of platform. The other thing is this Docker helps us for the faster development and deployment of the applications. So how it is going to help us in a faster development and deploying the application? We know that Docker images are something which comes with a pre-packaged environment. Suppose, let's say, applications with all their dependencies are going to be bundled into a single unit by eliminating the need for manual configuration. And then we are going to install this Docker image on each server or on each environment. So this concept significantly reduces the deployment times and streamlines the development of the Docker workflow. That's another advantage. The next advantage is it will simplify the updating process and also the scaling process. You can easily scale up or scale down the requirements of the containers depending upon the requirement and also depending upon the traffic that is coming to the application or workload that is coming to the application. The next advantage is Docker will help us in efficiently using the resources and efficiently scaling up the resources. And that's why we can call it as a lightweight and efficient tool. And these Docker containers are something that are going to work in an isolated environment. This we are actually aware that how Docker is going to run in an isolated environment. The other advantage is it improves the collaboration and also the version control system. So by using Docker, we can standardize the images. Now, what does it mean by standardizing the images? Docker actually promotes the collaboration by providing a standardized way to package and share the applications. So you can share the Docker images with anybody that are available in the Docker registry or in the Docker hub. So teams can easily share the Docker images, ensuring that everyone is working with the same environment. That's called as standardizing the images. And the next one is version control for the application. By using Docker images, they act as the version control system for your applications. You can easily track the changes. You can easily roll back to the previous versions if it is needed. And you can also ensure the consistent deployments across the different environments. That is also a possible scenario with respect to the Docker. Coming to the other things, such as it will increase the productivity of the application, it will increase security to our application. All these things can be done by using Docker. So we'll be practically seeing each one of these advantages in the real-time scenarios once we enter into the actual Docker practical labs. Now, let us understand how this Docker architecture is available. Docker architecture typically follows the client-server architecture. I hope you have an idea about what does it mean by client-server architecture. Let's say you have the client, which is basically the web browser, you can say. And if you want to interact with the client, for every client, you will be having the server in the backend. Now, if you want to communicate between the client and server, here what we are going to use is we are going to use a component which is known as RESTful API. What does it mean by API? Application Programming Interface. So if you want to establish a communication between the client and the server, we are going to use the concept of APIs here. Now, in the Docker concept, we will not be having a server. Instead of server, we will be having the Docker engine. Now, by using Docker engine, what we are going to do is we are going to build the Docker containers and we are going to run those Docker containers on top of the host operating system. So Docker always follows the client-server architecture. The client will be there and a server will be there. But in the place of server, we are going to have the Docker engine. Now, what does it mean by Docker engine? Docker engine is the place where we install the Docker. We'll be talking about the Docker terminology in some time. So Docker engine is responsible to build the containers and to run the containers in an isolated environment. So this is basically the Docker architecture. Let's understand this Docker architecture on a large scale. Let's say you have the infrastructure. Now, in order to create the hardware components or in order to create the infrastructure, we are going to use different cloud service platforms such as the AWS cloud, the Microsoft Azure, the GCP cloud, or any other types of cloud. Now, once you create the infrastructure by using any of the cloud service providers, then we are going to install the operating system. And that operating system, we are going to call it as the host operating system. Now, on top of host operating system, we are going to keep the Docker engine, where we are going to install the Docker software. Once we install the Docker software in the Docker engine, we are going to build the containers and we are going to run the containers on top of Docker engine. Now, on top of one host operating system, can you run only one container? No. So on top of host operating system, you can run multiple Docker containers according to your requirement. So that is again one more advantage of working with Docker. So Docker is basically a lightweight concept where you can run multiple containers on a single EC2 instance or on a single virtual machine. That's basically the Docker architecture. Again, let us go more deep into the Docker architecture concept. So to explain this, let me show you this particular diagram where it includes everything that is related to the Docker architecture. So Docker architecture consists of three major components. The first component is known as a Docker client. The second component is known as a Docker host. And the third component is known as Docker hub. Remember, these three are very much important. Docker client, Docker host, and Docker hub. So inside Docker client, we are going to execute different Docker commands. So these are basically the Docker commands: Docker pull, Docker build, Docker run, Docker start. We'll be seeing all of these commands practically from the next session onwards. So the first thing is the Docker client, where we are going to execute the commands related to the Docker. And inside Docker host, we'll be having a Docker daemon. We'll talk about this one. What exactly is Docker daemon? And inside the Docker host, we will be creating the containers and we will be creating the images here. And Docker hub is a place where we are going to store the Docker images. We have already understood this one. So let's understand what actually is Docker client. So Docker client is something where we are going to interact with the Docker. So by using Docker client, we are going to execute the Docker commands. Once you execute the Docker commands, you are directly interacting with the Docker host. In the Docker host, what exactly we'll be doing is Docker host is the place where we are going to install the Docker. So host is nothing but which is going to host the application or which is going to host the software or a tool. So here, what is the host? Host is basically the EC2 instance. Inside the EC2 instance, what we are going to do, we are going to install the Docker software. So host is a place or host is the thing where we are going to install the Docker software. And here inside the host, we will be having the Docker daemon. So daemon is something that is going to manage all the Docker components. Now, what are the different Docker components? Docker components such as the Docker images, Docker containers, Docker volumes. These are something that comes under the Docker components. So host is the place where we are going to install the Docker. By using host, we will be having the Docker daemon. So Docker daemon is something which is going to manage all the Docker components. What are the different Docker components? Docker components include the containers, images, and the Docker volumes. And then comes the next one, which is known as a Docker hub. Docker hub is a place where we are going to store all the Docker images. It's basically a public repository or a public platform where we are going to store the Docker images. So it manages all the Docker images that we are going to create in the Docker host. Okay, so this is in general about the Docker architecture, the components that are involved in the Docker architecture. This particular slide is very much important to give an better idea about the functionality of each Docker component. So try to understand this particular thing in a better way. So the first Docker component is known as Docker host. So what is a Docker host? The place where we are going to install Docker is known as a Docker host. Now, where exactly we are going to install the Docker? It can be on a physical server or it can be on the virtual machine. If it is in the AWS cloud, we are going to launch one EC2 instance. Inside the EC2 instance, we are going to install the Docker software. That is the place where you are going to install the Docker is known as a Docker host. And the second component is known as a Docker file, which is very, very important. By using this Docker file only, we are going to work with Docker. Docker file is something which contains the set of instructions or the configurations in order to build the Docker image. Without having the Docker file or without writing the Docker file, we cannot build a custom Docker image. So Docker file is something which contains the set of instructions or the configurations that are required in order to build the Docker image. And then comes Docker image. So what is a Docker image here? Docker image is basically a package that contains the operating system, the source code, the project dependencies, the libraries, the tools, everything that is required in order to run an application. We are going to package all those things into the Docker image. Okay, once the Docker image is created, we are going to store that Docker image in the Docker Hub. Okay, we are going to store that image in the Docker Hub. Docker Hub is also called as Docker registry. So what is a Docker Hub here? Docker Hub is a public repository where we are going to store the Docker images. So what is a Docker image? Docker image is a package of everything that is required in order to develop an application. So once we get the Docker images stored in the Docker Hub, the next component is the Docker client. Docker client is something whenever you are going to execute any Docker command, this Docker client will start and it will interact with the Docker engine. Once it's interacted with the Docker engine, it is going to execute all the commands. So in a simple way, Docker client is something where whenever you execute any Docker command, Docker client is the one who is going to respond to us. Let's say I'll execute a command called Docker pull. So whenever you execute a command called Docker pull, Docker client will respond to that command. That's called as a Docker client. The next thing is the Docker engine or the Docker daemon. This Docker engine or Docker daemon is basically a software using which we are going to create the Docker images and the Docker containers. So if you want to create a Docker image or a Docker container, we need to have this Docker engine or a Docker daemon. So anything we can call it as. It can be a Docker engine or it can also be called as the Docker daemon. And all the Docker commands, whatever we are going to write, they will get executed in the Docker engine itself. So in a nutshell, Docker engine or the Docker host, they both almost represent the same thing. So Docker host is the place where we are going to install the Docker. Docker engine is the place where all the Docker commands will get executed in order to create the Docker images and in order to run the Docker containers, or in order to create the Docker containers and run the Docker containers. And the last one is known as Docker container. Docker container is basically a standardized unit that has everything that is related to the application or in order to run the application. We have talked so much about the Docker containers. So if you have any doubts related to the containerization concept or the Docker containers, I would recommend you to watch the previous videos, which will give you a complete idea about the Docker container concept. By using this Docker container, we are going to execute our application. So in simple, you can call the Docker container as the runtime of our application. Okay, it's basically a runtime of our application, or you can also call runtime instance of our Docker image. So these are the different components that gets involved in the Docker architecture: Docker host, Docker file, Docker image, Docker hub or Docker registry, Docker client, Docker engine or Docker daemon, and the Docker container. Once you understand the difference between each and every one of these 7 components, it will be very easy for you to understand or to follow the next sessions, whatever I am going to discuss. Here, one thing that we need to remember is when you create the Docker image, then we can pull the Docker image and we can run the Docker image in any machine. Machine is nothing but the virtual machine, or it can be a physical server also. We'll be talking in detail about all of these things in the practical case scenarios from the next video onwards. Next video onwards, we are completely going to focus on the practical concepts. We are not going to bother much about the theory concepts so far. So whatever the theory concepts that we have discussed so far, they will be acting as a fundamental concept in order to follow up my next lecture. So if you haven't watched any of the previous videos, and if you are directly jumping to the next video that I am going to discuss, I would recommend you to please watch those videos so that you will understand the fundamental concepts. Whenever I discuss any theory concepts or the practical concepts in the next sessions, I will not be discussing in detail as we have discussed so far. So I'll be directly jumping into the concept and I'll be directly showing you how to execute the things and how to work with the things. So these are the different Docker components. I hope you understood what exactly the Docker components are. Now, let us understand the Docker workflow. So this is again one of the most important things, how Docker will work in the real-time scenarios in the backend of the application. So firstly, what we will do is we will write the Docker file. So what Docker file consists of? It consists of the set of instructions or the configurations. Once you create the Docker file, as a DevOps engineer, we have to create this Docker file. Nobody else will create the Docker file. We have to create this Docker file. In the Docker file, we are going to write all the configurations which are required to set up the application. Once this Docker file is created, then it will be acting as an input to the Docker. Okay, it will be acting as an input to the Docker. And for every application in the real-time scenarios, we need to create this Docker file. Without creating the Docker file, it is not possible to work with the Docker concept. Once we get the Docker file, or once we have written the Docker file, then we are going to build a Docker image by using this Docker file. Okay, Docker image is built by using the Docker file. Once the Docker image is built, we are going to run this Docker image and we are going to create the Docker container. This is the workflow. Once we create the Docker file, we are going to build the Docker image from the Docker file. Once the Docker image is built, we are going to run the Docker image and then we are going to create the Docker container. Whatever the images that we have created, we can store these images either in the Docker Hub, which is a public repository, or we can also store it in a private repository such as Nexus and the JFrog repository. So this is how the Docker will work in the real-time scenarios. I hope you now understood the architecture that is related to the Docker and also the Docker components that are involved and the importance of each and every Docker component and the Docker workflow. So if you want to know more details about the theoretical concepts that are related to the Docker, you can refer the Docker documentation. You can go to this particular website called docs.docker.com. You will be getting a complete details about all the Docker concepts, whatever we have discussed so far. In the next video, we are going to talk about how to install the Docker and how to work with Docker Hub and a simple fundamental concepts related to the Docker commands. Thank you.